representing the set of numbers whose decimal representations are neither terminating nor repeating. Represents the set of numbers whose decimal representations are neither terminating nor repeating. Last week we worked with rational numbers, which were fractions and decimals. This week we're working with irrational numbers. Anyone know the most notorious irrational number? Pi. In our class, the irrational numbers we're going to be working with are mostly square roots. So it'll be the square root of any non-perfect square. So for example, the square root of 2, or the square root of 17, or the square root of 20. I would not put the square root of 25, because that is just 5, which would make it a rational number. But as long as it's not a perfect square. Now your perfect squares are a number that is the square of a whole number. And that's what this chart is that you picked up on your way in. You do not get to use this chart on your next quiz, but you could, because you'll have a calculator, you could construct this chart, like on the side of your quiz, if you really wanted to. All that these are taking a number times itself. So 1 times 1 is 1, 2 times 2 is 4. Oops, here we go. 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. See what I'm saying here, guys? I'll just put dot, dot, dot. But on this sheet it goes up to 400, but you could keep going. 21 times 21, 22. But usually our numbers aren't going to be large enough that we need anything bigger than that. But today when we're breaking down a number, you'll want to divide it up into 2 factors. One of them will need to be a perfect square in order to reduce the number. So steps for simplifying radicals. And bless you, in case any of you learn this differently from another teacher, feel free, if you know how to do it from them, do it that way. I teach it in a way that I think is the easiest, but if you learned it a different way, you're welcome to do it. The way I teach it is to find the largest perfect square that divides evenly into the given number. And so for a lot of you, you'll want to take your calculator and actually keep dividing until you figure out which one goes in evenly. You'll factor that number into 2 square roots. You will check the non-perfect square to make sure it can't be reduced either. And then you'll take the square root of the perfect square and place it in front of the number. So let me do a little example here. So the square root of 20. Okay. You want to break it into the largest perfect square. So I would never break this into 2 and 10. Even though 2 times 10 is 20. 2 is not a perfect square, and 10 is not a perfect square. So we're thinking of that list that we had up there, 1, 4, 9, etc. Okay. So 4 would be the largest perfect square that goes in evenly. So you would break this up into the square root of 4 times the square root of 5. Now personally, I always put the perfect square first, because as soon as you take the square root of this, and to get 2, that number should go in the front. So this answer can be read 2 root 5, 2 square roots of 5, or 2 times the square root of 5. Those are the 3 ways you could state it. Okay? All right, so now let's do 72. Now most of you, when you see 72, what 2 numbers come to mind? 9 and 8. 9 is not the largest perfect square, though. So I'm going to show it with the largest perfect square that goes in evenly, which is actually 36. And again, if you didn't know that, you can take your calculator, 72 divided by 4, 72 divided by 9, until you see which one gets you a whole number when you divide it. Okay, so this one would have worked, but I'm going to show it both ways. So if you break it into the largest perfect square, which is 36, it becomes a one-step problem. The square root of 36 is 6 root 2, and you're done. Now, if you were to choose 9 and 8, I'll show that over here, because a lot of you will, and there's nothing wrong with it, it just makes it a longer problem. So square root of 9, square root of 8. The square root of 9 is 3. The mistake a lot of you will make is that you'll circle this and then move on to the next question. But you can't circle and be done until you're sure that there are no perfect square factors that can come out of 8. So 8 then would break down into the square root of 4 and the square root of 2. And that 3 kind of just comes along. Then you take the square root of 4, which is 2. Anytime you have numbers outside, it's understood multiplication. So you'd multiply the 3 and 2 together to get 6 root 2. So same answer, a lot more work. And the mistake is that a lot of you, when you get the square root of 8 or the square root of 12, you'll forget to keep going. So always keep going until you have no perfect square factors left underneath. And that's why I say sometimes using your calculator will help. All right. I must not have saved my flip chart last year because I had written these on every slide. I remember. At least I have videos showing what my pen is doing. All right, so whenever we're breaking down 50, again, we'll never pick 5 and 10. Ever, 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 ever. 5's not a perfect square, 10's not a perfect square. Instead, we'll pick what? 25 and 2. Square root of 25. Square root of 2. Take the square root of the perfect square, and we'll get 5 root 2. What will I break that into? 9 and 2. And if you can do it in your head without showing work, that's fine. But some students, when they do it in their head, they'll mix up the numbers and they'll actually write 2 root 3 instead of 3 root 2. So every year on the quiz, some people like have all their answers backward. And then how about 27? 9 and 3. All right, on the back, we're going to make them a little bit bigger. And we're also going to add in operations with square root, so multiplying, adding, subtracting, dividing. What do we think about the square root of 17? What would I break that into? Is 4 divisible into it? 9, 16. 17's prime, right? Its only factors are 1 and 17. So this one is actually a trick question. The question is the answer. Cannot be simplified. That can happen if it's prime. You could break it into 1 and 17, but you'd end up with 1 square root of 17, which is the same thing. Now we'll do one of these because you have numbers outside. You're going to leave the outside number where it's at. Do not multiply it in. You can't distribute it or anything. So we'll take the 52. Now again, a lot of you don't know what factors of 52 are, so you just take your calculator and start dividing. 52 divided by 4. And we'll get 13. Now, I can tell that that's the largest perfect square because 13, the factor I'd be left with, is prime, meaning it wouldn't be able to break down any further. So I'll break this into 4 and 13. Again, the 3 that's out front just kind of follows along for the ride. Take the square root of 4, which is 2, and we will multiply, not add, the outside numbers. Since there's no symbol, just like when you see 2x, it's understood like 2 times x. The same thing here, these are multiplications, so we'll get 6 root 13. Okay, and the numbers will get bigger. So again, 192, I don't know what the largest perfect square is, but you can just take your list, your little chart that you have. You could start at the biggest and work your way down, or you could start at the bottom and work your way up, whichever you prefer. So 192 divided by, like I know 169 is not going to go in, and 144 is not going to go in. So maybe start with like 81. That doesn't work because it gets me a decimal. 192 divided by 64. Ooh, it works. So as soon as you get a whole number when you divide, that's telling you that's your factor. So we're going to break this into 64 and 3. The square root of 64 is 8. And I should say, when you take the square root, do not bring the symbol with it. It now has become an outside number 8. And it's understood multiplication. 6 times 8 is 48. Now some students will say, Mrs. Bennett, shouldn't I break the 48 down into like 16 and 3? No, because it's outside of the radical. The only thing you are reducing is anything under the radical. So that's your final answer. Unfortunately, your graphing calculator can do a lot. It can't simplify square roots. So if you wanted to, you could type this in and this in and make sure you get the same number, the same decimal, to make sure you didn't change anything. Okay. I skipped a set of problems. Okay. All right, so we have multiplying, dividing, adding, subtracting. When you're multiplying, you literally just multiply anything inside with the inside and outside with the outside, and then you keep it where it's located. So for the first one, we'll just multiply those together. 19 times 3 is 57. So this will get me the square root of 57. And then we'll see if we can reduce it. 4 doesn't go in, 9, nope, 16, 25, 36. None of those go in. So that's just our answer because it cannot be simplified. Next one, they're both inside the radical. We'll multiply them and keep our answer inside the radical. So we'll get the square root of 36, which is 6. Okay, now we have some dividing ones. First, always check and see if you have perfect squares. Like, this is not a perfect square and that's not a perfect square. But since they're both under the radical, you can actually think of this as one big radical with 75 thirds underneath it. And then you can divide. So 75 divided by 3 is 25. And then the square root of 25 is 5. Now the next one, 16 divided by 25, is going to get you somewhere decimal. But they're both perfect squares, so you can actually take each square root individually to get 4/5. So they're all going to be a little different. You're just going to have to look at them and decide whether you want to divide them or want to square root them. Tomorrow we'll look at rationalizing the denominator when we need to. So make sure you realize, like, if this were 75 divided by the square root of 3, you cannot divide those because it doesn't have this one under a square root. But since this one was under, we were allowed to. But tomorrow we'll learn about rationalizing the denominator and review that. And then for E, what would we get? Julian?
4.
4. We should divide these and get the square root of 16. And that gets me 4. All right, put a nice big, like, division symbol, dividing up your paper, because it's going to switch gears from multiplying and dividing to adding and subtracting. And just like in fractions, where it's like a lot easier to multiply and divide versus add and subtract, the same thing goes here. So in order to add or subtract, you must have like radicands. My pen's working a little bit better. Like radicands. Radicand is the number under the square root. I tell students to think of them as like terms in algebra. So, like in algebra, (2x plus 3y plus 3x). The only thing you would be able to add were the like terms, right? The 2x and 3x, and you get 5x plus 3y. It's kind of the same thing, but the like terms are your like radicands. So we have 4 root 7 plus 13 root 7. Since we have matching radicands, we can add the coefficients. Just like we added 2 plus 3 to get 5, we'll add 4 plus 13 to get 17. But the like radicand stays like. We'll just say stays common. So do not add those and make it square root of 14. You just kind of keep it the same throughout, but you add the coefficients or the numbers in front. So the next one, you can see that we already have like radicands. These are all 2's. So we can actually just add or subtract the coefficients. So 5 minus 3 is 2 root 2 plus 4 root 2 will get me 6 root 2. And just think of them as like terms and keep that term light. Now let's make it a little harder. They're not like terms. You cannot add these and get the square root of 30. Wrong. Oh. They must be like. So some students will say, well, I can't add them because they're not like radicals. You can't tell me that unless you've already simplified everything first. So the square root of 3 cannot be simplified any further. But we can break this down into what? Good. Square root of 9 and square root of 3, which will get me 3 root 3. Now bring down the other stuff that we had. Okay, now remember, we always add the coefficients. The first one doesn't have a coefficient. Could we put something here? A 1, good. So now we have 1 root 3 plus 3 root 3, which is 4 root 3. A lot of students will think that's a 0 in front, but it's an imaginary 1. Just like when you see in algebra an x, you always know there's a 1x hiding there. Okay, and then all the last ones are the same type of problem. We need to reduce each radical. So this one can be reduced, and this one can be reduced. So we'll break our 18 down into square root of 9 and square root of 2. The 3 just kind of comes along for the ride. The square root of 9 is 3. Again, remember, you are multiplying the outside numbers together. So we'll get 9 root 2 for that part. And then bring down our plus sign. The 50, what would I break 50 into? 25 and 2. Square root of 25 is 5. Again, we multiply the outside numbers, so 4 times 5 is 20 root 2. And then if you do this correctly, it'll have like terms at the end, or like radicands, so we can add the coefficients to get 29 root 2. And then saving the best one for last, we have 3 problems in one, basically. So we're going to treat each of these like their own problem, and then at the end, combine any like terms that we get. So let's start with the 75. What should I break 75 into? 25 and 3. Bring down our plus sign. 12 will break down into 4 and 3. Never 6 and 2, because 6 is not a perfect square and 2 is not a perfect square. So again, when you're doing this, you're still thinking of that list. 1, 4, 9, 16, 25, 36. Those are the numbers you want to think about. Bring down our minus. And then 48 is the most confused number for this. People want to do 6 and 8, of course, but 6 is not a perfect square and 8 is not a perfect square. And then you guys will do 12 and 4, which works, but it's not the biggest perfect square. What's the largest perfect square that goes in? 16. If you pick 12 and 4, you'll just have to keep breaking the 12 down into 4 and 3. And then you'll see that we have square root of 3 in each of them. So now all I have to do is simplify a little bit. So the square root of 25 is 5. So I multiply 6 and 5 to get 30 root 3. Plus the square root of 4 over here is 2. Again, multiply our outside terms. 3 times 2 is 6 root 3. And then the last one, the square root of 16 is 4. So we'll get 4 times 4 is 16 minus 16 root 3. And then we just add or subtract in order from left to right. So adding these, we get 36 root 3. 36 root 3 minus 16 will get me 20. So just make sure you always simplify before you add or subtract. All right, 3 closures for you, and then the homework you guys can get started on. Whenever you're finished with the 3 closures, just raise your hand, and I'll come around and take a look at it, and I'll put a check on your paper if you get it right.